Welcome back. So we've done a whole setup. We walked through, getting everything up and running and getting our project ready to go. So I think it's about time we started building this game.
That's good. I'm up for that.
Are you pumped for it?
Yep.
You ready for this?
That's right. Let's do it.
All right. So I guess the first thing we're going to look at is creating the map.
Right.
So the place that we want to play.
Yeah. It's always good to start with that.
It's usually,
where's my world?
Yeah, that usually helps, right?
That's right.
And then we're going to create the player so that we can actually interact with this world.
That's right.
Makes sense. Okay, so first up, well, I guess I should go through the module overview first. So in this module, we're going to walk through a few different things. We're going to take a look at setting up the map. Mm-hmm. We're going to talk about how we're using a 2D array system to actually create the maps. We're going to talk about preloading sprites.
So all of your images and your graphical content.
Which is a really good thing. It's, some people might think of that as an advanced topic, preloading images, but it's almost a necessity nowadays, right?
Yeah, and it's much simpler in the framework that we have.
Exactly. And then we have adding the map to our stage. So we're going to actually take that map and put it into our...
Take the map data, take the sprites, combine it together.
And put it on a screen. Yeah, when we refer to our stage, we're basically referring to the screen that we're looking at.
Right, where you want to place everything on a stage.
We'll explain that a little bit more in depth afterwards.
We'll get into it.
Yeah. And then we're going to take a look at creating a player.
Yes.
Right? And then we're going to add some functions and controls to actually move this player.
Yeah, well, you got to make sure it works.
Yeah, exactly, right? So I guess we're going to do some on-screen controls since we're going to be targeting mobile, as well as you're going to show how we have other controls set up for the web as well.
Right, we're going to bind it to keys because Enchant.js has all that functionality as well. It has a little bit of a different way to do it. It's still simple and straightforward. It's just how you specify what key there's a point of confusion that we'll take a look at. And then we'll go to the on-screen controls for all of our touch devices and tablets and phones and so on as well, and get those on the screen.
I think in this module we should break something and then show how we debug it.
Actually, that's...
Does that make sense?
That makes sense because when you're dealing with JavaScript, we are using Visual Studios, but Visual Studios does not compile.
For the Cordova, the way we're set up, we can't actually do debugging in Visual Studio the way you normally would do, with like add a breakpoint, step through inside of Visual Studio, because we've got this all wrapped in Cordova, which basically is serving up the website, right? So when we want to do that, we have to go to an external debugging system. And in this case, we're going to use Internet Explorer because at the end of the day, we're building a web game, right?
Right. And again, most of the browsers now have these developer tool consoles hidden in there. Most of them are bound to F12. If you're just looking at a website,
just start hitting F12.
You are now. Just hit F12, right, or whatever, and you'll just see all these things pop up all over your screen. Those are the developer tools a lot in most of the browsers, and they're in there because, again, originally, JavaScript way back and so on, we needed some way to play around with this, and it was getting frustrated. In HTML5, there was really no debugging, but we weren't really doing anything necessarily, or in the older versions of HTML, you weren't necessarily doing anything too complex programmatically. It was, here's my document, format it, display it, let people read it. Maybe then we added buttons and some animations, but that was all done in other things, usually like Flash, and brought that
or
in.
even CSS, right?
Right,
a lot of
CSS,
animations and stuff on websites are done in CSS
exactly.
instead of in JavaScript.
But nowadays, we're putting a lot more programming and scripting behind everything we do, and on top of that, we've pulled it out of things like Flash and so on, and HTML5 and CSS have picked up the animation ability of Flash, some of the Flash techniques and so on, and built all that and wrapped it all in there. So we've moved out of that development environment as well and brought a lot of the coding right into the HTML5, the JavaScript, and the CSS, and brought it all together. But there's no real developer suite specifically that most people use for that, but everybody uses a browser to view it. So all the browsers built in development tools for you to look at the code, place breakpoints if you're used to that from C or C++ or C# in Visual Studios, anything like that, and actually see what's going on, when it's going on, and what's going wrong if you can figure it out where it is, and then repair it and move along.
Yeah, and we'll show you all those steps so
right,
you can actually get a good feel of what we're talking about and how how we're going to set this up and how you actually go through it.
So just remind me to break something at some point.
I will.
If it happens accidentally, then it'll be perfect, and we can just do that.
Yeah, accidentally.
All right, so let's take a look. We're going to deal with the map first, right?
Yeah, so the first thing we're going to do is we're going to take a look at our map.js file. So we're going to create a new JavaScript file that's going to store all the data that we're going to use for our actual map.
Right.
So we'll walk through that. And in our case, we're using 2D arrays to actually hold the map data, which basically maps back to a certain image, right? And we'll explain that as we get into the 2D arrays.
Yes, that's right. So if we jump into my code here, it does look like I fell asleep at my keyboard, but that's on purpose. Okay, this means something to programmers and those of you that have some experience. This is one way to preload a two-dimensional array. That's what a 2D array is, two-dimensional array. Mm-hmm. And this is all in my map.js file. So it's hard. So
why don't you show them how to show them how to create the map.js file first.
Well, again, right-click, add, new item.
Yep.
And then when it pops up, again, we're in Visual C because of Cordova. We just want a code file, and you can go ahead and type in.
Yeah, call it junk.js, I guess, in this case.
We'll just make a new...
And make sure you change the...
Yeah, make a new file just for fun. We won't use this one, but there you go. And I hit add, and now I have my junk.js file with nothing in it.
Formatted to JavaScript.
Right, and it's ready to be highlighted and colored properly for you automatically by Visual Studios as a JavaScript file.
Yeah, IntelliSense.
That's right. So we don't need that, guys, so now I'm just going to go remove it. And, of course, if you spelled it wrong or whatever, you could rename it, but we're just going to delete it permanently. It's gone. And this is our map.js file. Now, the two-dimensional array, it is a variable. Mm-hmm. So we're going to specify this using the keyword var in JavaScript. That's how we go about doing that. And we go ahead and we give it a name. Map data seem to be fitting. Makes sense. Whenever you're doing any kinds of variables, okay, if you're new to programming, right, these are the topics for you. Name things concisely, but name them in such a way that anybody else reading your code has an idea of what should be in the variable. Okay, so map data,
Makes
most
sense.
people will understand what these numbers are supposed to somehow do, somehow supposed to create a map out of this data. So that's all we want. We just something simple, something concise, put it in there, and you can also see there's ways to. We use a lowercase letter on the first word and always uppercase letter any other word after that. Camel case.
Camel case, yeah.
It's a typical programmer thing. And so we're just trying to follow those typical techniques throughout this demonstration. Now, what happens is because this is a two-dimensional array, and actually I'm just going to go down here at the bottom, and I'm just going to, again, start out. If I had a var, and this one I'll just call map fun. All right. Typically, a two-dimensional array, so you have one dimension. Whoops, and it put on some curly brackets there. So one dimension would be one set of brackets, and I can fill it in with a list of values of whatever I wanted, okay, and comma separate them. Now they could be, depending on the type of variable, numbers or words or anything like that. And that's just a simple array. It's nice and easy. It's one-dimensional, and these are all numbered by an index. So if I wanted to access one of them, I would have to do something like map fun, and you can see IntelliSense helping me out, trying to show me what to type. And then I would say square bracket and state the index value of what I wanted to access. So if I said 0, which guy would that be? Well, that's actually 0 is the first place.
Yeah, because machines count from 0.
Right. So it is a valid number. 0 is a valid index. So that is the first one. If I was to say 3, then it would be 0, 1, 2, 3. It would be that value that it would return to me. All right, now, two-dimensional arrays from there, I mean, you have one dimension. Really, a two-dimensional array, think of it as a grid-like structure, like a checkerboard or a chessboard or something like that. And two-dimensional arrays come up a lot in gaming because we have a lot of grid-based stuff. In fact, in this game, we're using a tile-based map. So this is why we're using a 2D array for our map, is we have a bunch of rows, which is a one-dimensional array effectively, and then we have so many of them all lined up in columns, so we have a grid-like structure. So a two-dimensional array is going to give us one dimension, and then we're going to take it and extend it in another direction for the second dimension. Okay, so in terms of the data here again, we would basically say, well, this is one dimension, and then I could have another dimension of some other data. And again, this is just garbage. So now I have a second row, and you can see already, or it's hard to see there, but there's a little red squiggly line saying, hey, what are you doing? You're
IntelliSense doesn't like that.
Right now, what I have to say is, okay, well, what I meant was I'm actually going to have a array of arrays. So I've put the content now really set up like, sorry, I should put this up here so it's a little bit easier. Now you can see the grid starting to form. If I just type it like this, you start to see that, it's building that row and column setup. Guess I have to keep all the formatting so you can see that everything spaces out right, but it's all there in that order. So that's effectively what we've done here, and I've just done it on a grand scale. Okay, this is a huge map. I don't even remember how many rows and columns I put on this one, but it's very large. Each one of these represents a tile in our world that you can effectively move the character and step from one to the next to the next.
And by tile, you mean an image of, like, say, a ground or whatever it might be, but it's an image.
An image of water, an image of grass, an image of dirt.
When you're thinking of a 2D RPGs like this, when you say tile set, you're basically talking about the image files that you're using to produce, like, say, a map or a character or a building or whatever it might be.
Right, exactly, yes. That's exactly what we're talking about. So I have my map data. Now, the other thing in this map.js file, if I scroll down here, is foreground data. Now, again, I tried to name the variable as concisely but as relevant as possible. So foreground, that means in front of.
Yes.
Okay, so in front of my map data. In other words, again, it's a two-dimensional array, and some of this gets a little scattered, as you can see, because I have values over one digit now, so it's not quite perfectly aligned, and that doesn't matter. The code could care less. In fact, I think there's even two spaces here. Yep, there's two spaces there for some reason, and white space
doesn't care about
white space does not matter. Okay, for the majority of things in most languages, HTML and so on.
Try to keep it to a minimum, though. It makes it a little hard to read when you've got a lot of weights.
Well, actually, I believe the double spaces there is because it fills in the space for the minus sign.
Okay.
So it still tries to line up, tries to line up the column, but at some point I fell asleep and I didn't go back and fix all that. But this one now is going to be, as you can see here, we only had ones and zeros up in this one, really. And then in this one, I have threes. There's some 13s. We got negative ones, and so on. There's a 15. Okay, these are all going to be indices of, again, other tiles. So we don't know what kind of tiles necessarily yet, but we've laid out a plan. Okay, in our game design, our game development, which you should always do ahead of time, and I preach that, and we have a class on that, and all that kind of stuff. But the idea is that this is just for the computer to recognize which cell from your sprite sheet that you're talking about. And I'm just going to go over here, and here is the one, and again, that we're playing around with, and you can see that each one of these is broken up into a different image. They're all effectively the same height. They're all the same width. We've gone with a standard, I think, 16 by 16 is pixels is what we've done.
We'll take a look at that once we get into the code. We'll walk through how it's set up.
This green, dark green checkerboard, that's not drawn in the image. That's Visual Studio is actually just putting it there so that I can tell there's transparent pixels here. So that's not part of this image. It's supposed to be transparent. That's just a background. So what we have is we can see we got some water, we got some grass, we got a guy with a little cowlick going on here. I guess that's me. And we got a tree, we got a cat that's waving with this big jingle bell on him. And here we have the same guy walking in various directions. This is going to end up being our player animating in the 4 cardinal directions that we're going to allow him to move: north, south, east, west. Then we have another tree. It's exactly the same as the other tree. But we've put it in here because we're going to do a trick later on. We'll get to that when we get to collisions and stuff. And here I have half of a water tile. And again, that's just going to be a trick. You'll see what I use that for in a bit. And then we got one other character over here. He's got his little hat on, getting all angry or something. And so he's going to be our bad guy, one of our bad guys when we get to that part.
He looks like a bad guy.
There you go. He looks like a bad guy. His hat's twisted. That's not right. So this is the sprite sheet that we're going to be using. Now, again, programmers, generally, we go 0, 1, 2, 3, as if this was a single dimensional array. Okay, so we have indices for each of these. So 0, 1, so grass.
Yeah.
If I just pop back over here to this map file, there's a whole lot of ones.
There's a lot of ones.
That's because there's going to be a lot of grass.
But I see some zeros at the bottom.
There's some zeros at the bottom, so if I go back again to our sprite sheet, there it is. 0, First one, water. So I expect just from looking at this that I'm going to see rows of grass with some water at the bottom. Okay, so that's what we've laid out as the background, basically our floor of our map. Now, the foreground is going to lay on top of that. Now,
actually, do you want to switch back to the slides real quick? We actually have a picture of that. We can show them what we're talking about there.
Just flip over there.
So if you see down here at the bottom, obviously the trees are being added in on the foreground.
Right.
But if you look here, we got a whole bunch of grass, and then at the very, very bottom, we have some
water. Might be clipped by the
Yeah, it might be a little clip there, but yeah, there's water down there at the bottom, so that makes sense, right? That's our background.
That's what we expected to see, yeah. So the foreground layer now is going to give us those trees, for example, but also -1 does not, what is that in our sprite? Well, this is 0, so -1 is nothing.
So we're leaving it blank.
Exactly. We've signaled to our code that, that doesn't exist.
Yeah, you don't need to draw anything there.
If we see -1, we're going to assume that means null data. Don't put anything here, and that's the way we're signifying it. And then we got some 3s, and if we go pop over here again, 0, 1, 2, 3, that's why we are seeing our trees.
Okay.
All right, so that's how this data is configured and laid out. And then there's also some 13s in here, which if I pop back over here, 0, 1, 2, 3, 4, 5, 6, 13, just skip ahead. It's this other tree. And we're going to do some fun things with those two trees there that some RPG veterans probably can guess what we're going to do in a minute when I only have one random path of trees that are not like other trees.
Shh, we'll leave that.
There you go. So that's our data layout. That's all we put in our map file.
Yeah.
Okay, so we've just segregated that data out so that it's easy to reference, easy to find, easy to make changes. We don't have to go digging through the rest of our game code to look for these large data structures.
What screams to me right away when I'm looking at this, on the programmer mind clicking away, is I can build an editor for this pretty easy.
Right, you could. I mean, you could write a small app in C# and XAML or whatever you wanted that could basically just let you pick a sprite sheet. Right, it would bring it up. You could specify the width, and then basically just click or drag them all out wherever you wanted, and then have it
export my arrays.
Right, just have it pick. Okay, what image was it, and turn it back into a number, and then feed that out maybe as a comma delimited structure, or actually write your own little parser that fills it out in this nice little two-dimensional array that you could then drop right into your game. So
that kind of sounds like a project for another day. I like that.
It's almost like a project I gave you one time.
Yes, actually it is.
So that can definitely be done, and a lot of developers will do that. Once they've got their game engine and they've got it set up working the way they want, you want other people to be able to do this. They may not understand code.
Well, your level editors, right?
Right.
All the games out there, a lot of the new ones are coming out with level editors to allow the users to kind of create their own worlds to play in, right?
And original modding tools for older games and so on came about because the developers would make tools to assist themselves once they knew what the engine wanted, how the engine wanted it, and so on. They would build. Those same guys that program the engine or another team would build the tools that facilitate other people like level designers and developers and artists to basically get their content in. Mm-hmm. And that's, you want to know what you're trying to do before you try to build that tool, but sometimes they run in parallel and causes you a little bit of juggling and recoding back and forth. But really that's the normal process. And then you can make simple tools like this once you know what the data should be laid out like to go ahead and drag and drop away or whatever kind of features or tools you need to convert data into your game.
Now, is there other options that we could have looked at? Like maybe we did an XML file?
Sure, you could do XML file, which I'll just pop back to HTML. XML sounds like HTML.
Yes,
there's a reason. HTML stands for Hypertext Markup Language. XML is Extensible Markup Language. In other words, they made a markup language where you could make any tags you wanted. So you didn't have to stick to pre-configured HTML, head, meta, or whatever other tags are out there. Mm. You make your own tags, and you give them their own attributes, and you specify whatever you want. So really, it's not necessarily a language that anybody could interpret just one-off. Like if you handed them an XML file, they can't just look at it and be like, wow, I'll run this through my game. But it allows you to store data in a nice way that you could then write a little parser algorithm that would go and find the head element, look for meta tags inside that, look at what type they are, pull out the content, look at what type it is, pull out the content, and fill it into an array for you or something like that. So you could do a XML type approach, but for something as simple as a tile-based map,
it makes more sense to maybe just do it in an array, right?
There's too much overhead. I mean,
well, you could do anything. You could do JSON. You could do a bunch of different stuff. But at the end of the day, this seemed to be probably the easiest one for the simplicity of our game, right?
This is definitely the easiest one to get up and running from a coder standpoint, but not necessarily the best for somebody else that's a non-coder that needs to work with you. So when you have those level designers or somebody helping you, then you might want to move to XML or something like that, because it's a plain language system.
And they can read it. It's more English than it is.
You could look at the tag and say, this is the level tag, so now I know everything in here is in this level. And you give it a name, forest. And then they could start putting down like tree tag, tree tag, tree tag, tree tag, and put where all the locations are for each tree or whatever.
That sounds vaguely familiar.
Yeah, exactly. So you could do all of that. And again, that's great for people like level designers and so on to work with, because they can immediately sort of read and get an understanding for what is going on and how it works, and just run with it with very little get up and go. Whereas describing, again, code and which numbers equate to which image.
Well, if they just saw that, like if I was an artist and I just saw a pile of ones, I'd be like, what is that?
Yeah, it's not as directly readable. It's not human readable. And again, it's more for us coders just fooling around so we can quickly throw together a prototype and be like, look, this is a game we want to make. Now we need a full team. Let's go for it. Let's go do that. So that's
it's just because we love math so much. Everything's got to be numbers.
Sure, right? That's right. And we like to count from zero just to confuse
just
people.
Because.
Awesome.
So that's a little bit about like how the map's set up, how we're going to actually pull it in, and how it's kind of mapped. So let's take a look at actually setting up the map, right? Getting the code in place and everything. So I guess the first thing we should look at is preloading our sprites.
Right.
Now, I mentioned before that this is kind of, back in the day, it used to be considered an advanced topic of preloading your sprites, right? Why would you want to load them before you need them? Well, nowadays on mobile networks and stuff, it kind of makes sense to preload everything up front, right?
Right.
Well, the majority of everything.
Yeah, you don't want to preload too much because you could overflow the memory available to you or whatever. You want to just start loading what it is you're going to need in the near future. And
cuts down load times as well, right? So
right.
You don't see loading screens or anything like that.
You don't want interruptions in gameplay. A lot of games unfortunately have to do it once in a while because they're dealing with so much
stuff,
data.
Yeah.
Yes, that's right. And in this case, we're dealing with a little bit of data, small game, but it is being streamed over the web or on your cell phone connection or whatever. So we need to make it as small data-wise as possible just to not overwhelm the system. And you can even get it when you're in spotty cell phone area or whatever.
Exactly.
So yeah, if we pop over to the code here, I'm in my second file that we need, which is our game.js file.
So why don't we walk right from the beginning of this folder or this file down a little bit, because I'm seeing here a lot of setup code.
That's right. Well, so the first thing is we're calling enchant.
Yes, makes sense.
Okay, that we already have enchant in our project. We imported it, and this basically kicks it off. Yeah. It sets up everything that enchant needs to run.
So creating our instance of enchant.
Right. So we're basically just constructing all the data we need. We tell it, please set yourself up, and it's happy to do that. and then this next part here, window.onload. So this is, if you've done any JavaScript and web programming before, basically when your browser kicks up and they visit your site, wherever it is, when the window is done loading, this function will get kicked off, whatever we specify here. So we're not giving this function a name, and for those who are experienced programmers and so on, this may seem odd, like why do we have unnamed functions? It is
it's a very JavaScript style of
it is a JavaScript way to do things, and again, it is sort of an older language as well, but it was sort of not meant originally for gigantic game programming or anything like that. It was for simple scripting, and so you didn't really need to refer usually back to a function.
Yeah.
So it was okay.
But so from what I'm reading, it's basically we're creating a variable. So our variable name is window on load, and then we're assigning that variable a function.
Right. So that when the browser kicks off, it will the window class will say, hey, what should I do when I'm done loading, and call all this code down.
So if we wanted to call window on load again later on, we would just say window.onload, and then our brackets, right?
Yeah, you could play around with that. It's not suggested, obviously.
Oh yeah, not this specific function, but I mean functions in general.
That's more what we'll see down here when we get into the functions and stuff like that. So the first thing we need to do is actually create an instance of our game.
Okay.
Okay, and game exists as effectively an object
inside of Enchant.
I'd call it a class, but this is JavaScript, so it's not really. So yeah, it's an object inside of Enchant that we're going to utilize, and it wants to know our height and our width for how big this game is going to be. So we're going to pass in just our window screen height and our window screen dot width. And
so
again,
depending on the size of it's going
so it'll just fill the screen.
Whatever.
Yeah, no matter what it is. And this is that key binding part I was going to talk about.
We'll
we're going
get
to come back to that,
after,
so we're not going to worry about that right now. And the other thing we have to do is tell it a bit about the sprite sheet that we're going to deal with.
So the images we just saw a little while ago with the guys and the trees and the water and all that.
Right, this guy right here. So how wide is this and how tall it is? Well, I already said they're 16 by 16 in terms of one tile, so it's 16 tall. And then however many long times 16 is what we want. So we've gone back and it turns out it's 256 is the answer. So we put in 16 and then don't worry about this one right now. We'll come back to that one. That's a whole different sprite sheet, which you can see right here, items.png. So this is our sprites PNG. That's the one we were just looking at with all of our characters. And to load it, we simply call game.preload, and Enchant will take care of getting that image ready.
Oh, I like that. That's pretty easy.
Yeah, we don't have to worry about anything else. We don't have to track its loading progress or anything like that. A lot of people used to have to build little loader codes that would just check, do I have all the data yet? Do I have all the data yet? Do I have all the data? Oh, I do. Okay, go. And you can't do anything else while that's happening and so on, because you can't, if you try to access it before it's done, you might crash or hang your system and so on. So it's all handled by Enchant.
Makes sense.
We don't have to worry about that.
Let's skip over the items one because we're going to come back to that.
We're going to come back to all that. There's other things we can set, such as the frames per second we'd like our game to run at. Now, there are...
I know it's set at 15, and I'm just imagining right now all the viewers going out there, why are they running it in 15
Why is it not 1080p at 60 frames per second? Okay, no, we're not going to have that discussion. But frames per second, 15 is actually generally even... What was it? I think 12 even was what some Flash games would run at back.
Yes, yeah.
Through and it's enough to be responsive. It's a 2D game. It doesn't need to be 3D smooth and virtualized and everything like that. It's not supposed to look necessarily amazing. So 15 frames per second is good enough to give you a good feel for control, and it doesn't chug on your screen enough to really detract from it, because it's about half as much as you can generally see with your human eye on a daily basis anyways. So, and most TV is set to just slightly higher, 24.
Yeah.
Right, movies are usually around 30. And those are typically fine. We also don't want to overwhelm a browser back then. We write browsers and computers in general.
As we say frames per second, we actually mean ticks of the clock, right? So if we throw down too many frames per second, so if we boost this up to 60, we're sending 60 updates a second to our browser.
Right.
And that can overload. Speaking of the browser, right? Mobile devices might have the same issue, right? Yes. So it's a good idea maybe just scale it back a little bit. And in our case, it's a 2D game. Why do we need 60 frames a second?
It's a very slow-paced 2D game, turn-based. You move around, all that kind of stuff. So it's not required. Most of the time, you'll be sitting there doing nothing, thinking about what you want to do.
Yeah.
And so in this case, we don't need the speed, we don't need to overheat your phone, we don't need to drain your battery, right? So we're just lowering it on purpose just to be conscientious of those features of the audience that we're putting it out to.
Yeah, so I'm thinking from a beginner's mindset, and I'm hearing frames per second, and I'm hearing clock cycles. What does this all mean? What is the game loop?
So the game loop is effectively an iteration that every game has. You can have more than one in a game. They will all generally start out by initializing the game or whatever we're doing. It will then check for user input and so on in case the user's trying to do something. We'll then update everything in the game based on that user input and what those objects should be doing if they have AI or whatever, status bars and so on, blinking animations. We'd update all that stuff, and then we would go ahead and draw it to the screen, and assuming the game's not over, go back and continue on.
And
again.
so just to simplify that, we're doing that every frame.
Right.
Right? No,
so
obviously.
Frames per second means you're doing it that many times per second.
So we're running through our game loop, in this case, 15 times a second.
Right.
Okay.
Okay, so that would be what it's breaking down to. So in our game, our single sprite width and sprite height is going to be 16 by 16, so that we know the size of our tiles. And again, we're having a scale of 1. This is a future site thing, okay, that you may want to have a zoom in, zoom out camera into your game. Again, not letting the cell phone or the device do it specifically by pinch to zoom.
You're doing it directly in the code.
But we're taking control, and we might want to do that in the future, something like that.
Stop those cheaters in the RTS.
That's right. So again, the first thing we want to do, we want to make our map. And there is a map object in Enchant as well that we can play around with. And again, we just have to tell it the width and height.
Okay.
Okay, and it's going to give us a bunch of features that we're going to be able to play with. And we actually want 2 maps because we need one for our background.
Makes sense.
Which I labeled map. I should have probably called it background map or something like that. And then we have our foreground map, which goes over top of that with all of our items, so trees and so on.
Yeah, and that's actually the next point I was going to bring up is when we create these maps, we're actually creating 2, right? We're creating the one underneath, which is our grass and our water, and our tiles that basically the users or player standing on top of, if you think of it, right?
Correct, yes.
And then the foreground is things that we want to add to the world, like trees or maybe a building
things
or a
you
rock.
Can bump in, you can go behind. That's really what we're going to be using it for in this game. And you can have as many layers as you want. And some games have this. Parallax scrolling is done in that way. So when you're running sideways in a side scroller game, you have the trees whipping by, and then behind that you have clouds slowly going by.
And that's called parallax scrolling.
Right.
And
so it's
very
but it's
popular in
using
video
this
games.
exact same technique. It's basically the game is just split into multiple layers, one in front of the other, and in that case, we're just moving them at different rates of speed, and the farther away from the camera they are, the slower we're moving them.
Yeah.
And then you can also do the other trick. You can put something in front of the player's layer so that it looks like a tree or a stalagmite or something in your cave goes in front and blocks
gives that view of being really close.
That's right. It feels like it's up in your face, and there is something between you and the player, and it just gives it that depth that you want to feel sometimes. And that's sort of what we're going to use the foreground map in the water case. We're going to make it look like you're swimming by putting some things water in the foreground and some water in the background, so that it ends up, that half water icon ends up blocking your body, and it just looks like your head's bobbing around in the water.
Oh, we'll have to show them when we get through that.
Paddle around, exactly.
Cool.
So that's what we're going to do. So for now, we have 2 maps that we're dealing with. All right.
And I guess the next step would be we want to create a set map function to actually go ahead and bind all these sprites that we're talking about.
We have to link the data and the images in such a way, and that map class is going to help us out. So we have a set maps variable, which really is just going to be the name for our function that we can call. And now whenever we call set maps, which we'll see where that is in a minute, it's going to take that first map, which is our background, and it's going to tell it what image, okay, that's already a property of map, what image we are to be using for this map. So we pointed at game.assets sprites.png. Now you'll notice these square brackets again. It's because we're accessing an array.
Yeah. Above before, when we did our preload, we actually were basically creating an array of preloaded images.
The game class or object, when we call preload, takes those things and puts them in an assets array object that we can then pull them back out of when they're ready. And they've been ready for a while now at this point by the time we get to this. So we now pull that out so that it knows what image we're playing with, and then we need to load the data into the map. So they have a load data command or function that we pass our map data, which is the array from here, and to link it up. Now, the map class already knows that it's expecting to have a sprite sheet of some size, and that we're going to pass it a data or 2-dimensional data array of indices to link to that, and it does it
up
all
above
for
there.
us.
We actually set how big the map was with the sprite width and sprite height. And
in the game.
What I'm saying here is I'm thinking to myself, wow, we're really lucky we have Enchant abstracting all this for us.
That's right. We don't have to do a bunch of loops and everything linking up everyone and a bunch of if cases or switch cases on, oh, this is a 1, what's that mean? It's a this. Oh, this is a 3, oh, that's a tree. We don't have to do any of that. It's going to parse all that data and take the image file and link them all up for us behind the scenes.
And this goes to why we're using Enchant.
That's exactly why we're using Enchant.
Coding this ourselves, it would have taken a lot longer, and it would have been a lot more difficult of a process. That's right. Abstracting all this for us is really helpful.
Then we have to do the same thing for our foreground map. Okay, so it's going to use the same sprite PNG, and it's just now using the foreground data instead of the map data from our map.js file. So it's using this one down here. At that point, we have effectively created our maps that we're going to use for the game and the foreground map that we're going to use in our game, and it's all set up. Now, this collision data, we're going to
get to that, yeah.
Because again, this is the final production code. So that would be our setup map command.
So we've got our data in for our maps. We've got the images linked to our maps. We've created the maps, the linkage between the two. Right. So I guess the next step would be to actually add this to the stage.
Right. So down here, we don't have a stage yet.
Okay.
We're going to have to create one. And now, by default, there technically always is a stage sitting around in the game in Enchant. So what we're actually going to do is we're going to make a function that, again, allows us to set up the stage. Okay? And we're going to make a variable called stage, and we're just going to make a new instance of what they have as a group.
A group.
Okay? And what the group is going to let us do is just going to let us collect objects together that we want to display in one, chunk, basically. And one of those things is the map that we're going to need to add as a child to the stage. And if you've played around in Flash, this is exactly how Flash's ActionScript syntax works.
When I hear stage, I'm almost thinking that's how Flash does it, right?
It's a similar thing. So they have a stage object, and you can put things in there as a child. And what that means is it's the stage is sort of the parent that nannies them all around and make sure they're all in the right spot at the right time.
I like that analogy.
Yeah. So we're adding the map to that stage. So now if we display the stage to the screen, the map will be seen as well because it's a child of stage and it comes along with it. At some point, we are going to add the player to that stage as well.
So now, when I'm thinking of the stage, I'm starting to think stack.
Right.
Right. So is it a case of whatever you put on first is on the bottom?
Yeah. So what'll happen is it's like a stack of plates. Go to whatever your favorite restaurant is that has stacks of plates. You put a plate on, it goes to the bottom. You put another plate on, it gets pushed down. You put another plate on, it gets pushed down. And the first guy that comes along that's hungry takes a plate off the top.
Yeah.
And then that second plate is there. So the same thing will happen with our stages. And we're going to start calling them scenes, basically, at later on in the game when we get to our battle scenes and shop scenes and so on. And that's exactly how it's going to work. So we're going to have our main game world right now as our main scene on the stage, and then we're going to put another scene on the stack that you will see, and then when we're done with that, we'll pop that off. It's called pushing when you put it on, and popping when you pull it off. So we'll pop that off, and the one below it will rise up, and that's the one we see.
Okay, cool. We'll explain more about that when we get to the scenes.
That's right.
But for this, I'm thinking I probably want to draw my map first before my player, or I'm going to cover my player.
That's right. So that is exactly why we've added the map child, then the player child.
Okay.
So in that order. So again,
makes sense.
We'll come back to
the programming mind kicking in, right?
Yeah, we'll come back to when we throw the player in there.
Awesome. So we've got it set up on our stage. We've got the map set up. So I guess we need to trigger it.
Yep. I'm just going to scroll all the way down, all the way down past all this.
We got a lot of code in there to show later, that's for sure.
There's quite a bit in here. All right, so this will be faster. There
we go.
All right, so down in our game, at the bottom here, we do have a couple of other features that we're going to want to do. So here is our set maps function.
So we're going to, basically what's going to happen is when the game loads,
yes,
it's going to fire this function game.onload. So again, Enchant, being the great helper that it is extracting it all from us. And basically we're saying, hey, when this game's loaded, once you've finished all your loading process, fire off this function.
That's right.
And then in this function, one of the first things that we want to do,
I'll just remove that.
Remove that. We don't need to see that right now. Is set maps, right?
That's
so
right.
What we want to do is say, okay, you know what? Fire that function up at the top there called set maps that will actually walk through all those steps that we just did.
That's right. And then here we can see there's our set stage.
Makes sense.
Is going. And of course, because we were adding both the map and the player to the stage, we had to do set player first, which we'll get to that shortly, and then other things later on. So this is just going to be our game.onload. That's just the one that's going to kick off when our game is ready and ready to run. It'll go through, and this is all the setup code that we're going to do to get our game up and running. So set map and set stage are the ones that we've done. And if you just had game onload, my function, set map, set stage, and you don't have to have any of the rest of this,
we'd have that funky picture that we had in the slides.
That's right. You would effectively have that, except for
you need game start. Yes,
we do have to tell the game.
Yes,
start
that's a very important function, and that runs at the very end because we want to do all of our setup in advance,
right?
Get everything in place, and then when we're like, hey, you know what, we're good to go. we say game start and it fires up.
That'll be your final statement. And of course, if that brace there will link up all the way back to
our on window load.
As you can see, it's highlighted there.
Yes.
All right, so that would be the minimum code that you would need to get that image that we saw a minute ago up and running. You'd see your trees on there.
Have a little water at the bottom.
You'd have some water at the bottom if you filled it in, and you could fill this map in any way you wanted.
Well, you could add more to it, take some away, change up some styles. Maybe you want to add something. Maybe you add to your sprite sheet, you make your sprite sheet a little bit more. Maybe you add some sand, and suddenly you have a beach.
Exactly. So to do that, of course, you would have to go in to your sprite sheet, pull it up, add another brick at the end here in Photoshop or whatever.
But making sure you're keeping it in squares.
Yes, making sure it's 16 high and only 16 more pixels wide. Yeah. So you would change the canvas side, draw it in, and when you're happy with it, you could then go back to your map. If you wanted it as a background thing, because it's sand, then you could change all these ones right here to 17 or whatever your sand was. Fill it in there,
and then you'd have sand on the screen.
Well. There's one more step. You would have to go back in here and, of course,
edit the width.
The sprite sheet
Which makes sense because you just added more to it.
Exactly.
And the reason I said in squares and that is because I've had this bite me before where I've added a sprite sheet and it wasn't perfectly square. And all of a sudden, I'm getting like half images displaying, right? So that's why we said make sure that they're always 16 by 16. You could do 32 by 32, but whatever it is, make sure it's a square.
Yeah, and with any tile-based game, you're always wanting to pick an image size that gives you enough detail for what you want to display in the area.
In our case, because we're not doing a really high-res game, there's no sense of doing a 32 or 64 by 64.
Right.
That's right. 16 by 16 works fine for us.
All right, so...
You were mentioning player.
That's probably...
So I guess that's our next step would be adding a player?
What would we need to do with player?
Okay, so... Yeah, we'll jump back to the slides for a sec. So I guess the first thing we're going to want to do is create a sprite, right? Now, we've been throwing around this term sprite a little bit. Do you want to elaborate on what a sprite is?
Sure. A sprite is just a term for an image that usually represents a character or an object in a two-dimensional game. That's sort of where it came from.
Yeah.
So we call them just sprites.
Okay, makes sense. I just want to make sure that the people out there that maybe haven't heard that term before aren't like, you keep saying image and sprite and they seem interchangeable. I just want to make sure, right?
Yeah.
Very cool. So what we're going to do is we're going to create an instance or a sprite instance for the player, and we're going to basically use the built-in sprite class to create everything. And then once we get him created, we're going to go ahead and add him to the stage like we did with the maps.
Correct. That's the basics.
Okay. I know I kind of glossed over all the heavy lifting in there, but
we'll add to our player the ability to move around. And at that point, we'll have a movable character on our environment. And I mean,
this is starting to sound like a game, man.
Well, you can't win or lose yet, but however you want to define a game, you can still. It's a toy. It's a digital toy or experience at that point.
It's going to make you feel good when you
get
to this point.
That's right. It gives you something to go. So if we jump into the code here, and I'm still in my game.js file, and I scrolled by this on the way down to the bottom to say where we could start the game. So right under. Basically, there's that stage, add child, foreground map, and so on. I'm just under there, and we're going to make a variable for player. So this is in our window on load function still. And I'm going to make a player variable, and as we were saying about sprite, again, that's a common terminology they used. So in Enchant.js, there is a sprite object, and it takes its width and height. So in this case, it's going to be 16 by 16, and it basically will set up behind the scenes a couple of variables and a couple of
give it all its attributes and everything, right?
That a typical sprite would have in an RPG kind of tile-based game. So we also need a set player function. That's that function we're going to use at the beginning to initialize everything the player is going to need, and that'll go down where we had our set map and those functions we saw a minute ago. So in that set player function, we just have our player. The sprite offset is going to be how far along in that sprite sheet you might have. Now, in a lot of games, people will take characters and split them out into their own sprite sheets, and that's fine. You can
I've
go
seen
ahead
that a lot, yeah.
In that case, there's not going to be any offset because the first thing is going to be your character because all of his animations are just in that sprite sheet. In our case, we put all the sprites in one image, so we need a little bit of an offset to know where our character moving around was, where those images are. So that's what this is controlling, basically. So we're jumping along a couple of spaces to get to that main character, and I'll just whip open the sprites PNG. So 0, 1, 2, 3, 4, and 5.
Yeah, it's a cool way of doing it because if you think about it, it's less to load. If you can put all your sprites into one sprite sheet and you can manage it, and it's not going to be too much overhead.
In fact, that's a key thing about some browsers, that they can only load so many files at once in one stream. So by bringing together all the images you would need for any given level, you only have one file to load. That leaves you one file to load for your background music or something like that, and then one or two other files that you need for whatever purposes, because some of them have a limit to how many you can stream at one time. So we've actually done this because, again, it's our target audience is going to be mobile and web and everything like that, so we've done it in that manner. But it's not something you do all the time in all kinds of game.
It depends on the situation, right?
Yeah, always so. Back to the code. And again, we have our starting X and starting Y position, so that's where.
So X and Y, again, just for the beginners out there.
Oh, sure. So rows versus columns. So X usually is left and right. Y is usually up and down in a two-dimensional game. In three-dimensional game, it's different. Don't worry about that. There's another coordinate in there. You got Z in there, so you can, and then Y usually ends up being up in the world. Z goes into the camera, and X goes left and right. But for us, we just have two-dimensional, nice little screen. So we have X and we have Y.
So whenever we say we're moving on X, we're moving horizontal. Whenever we're saying Y, we're moving vertical.
Correct. That is what we're going to be doing. So we basically figure out where that player should be now by calculating his X position, by taking that starting point value.
Where we're originally putting him on the screen.
So we're saying 6 tiles, basically. Multiply it by his width, which is 16. That's how many pixels shunted over in the world is where he would be. So that's how that calculation rolls out, and then same for Y.
So the times game's sprite width and sprite height is basically the offset to constantly move him on tile.
Right. Everything in our game is 16 by 16, so that's the format that we're going. Now, direction is his facing direction. Walk is going to be used to control his walk animation. He basically has a 2-stride animation in any direction. So we just flip it from 0, 1, 0, 1, 0, 1 to figure out where we are. So for now, we just want everything to start default. So we're just putting in 0 for both those. And then frame is his frame of animation. So which one of these many images do we want to show for him currently? And we figure that out initially by taking, again, the sprite offset, so how many along to get to the first one.
So we move to the 5th sprite right away.
Right, and then we add the direction we want, so 0.
So that means he's straight ahead.
So he's facing us.
Oh, facing us, okay.
Yeah,
yes.
straight ahead. That's the one we've chosen as that.
Okay.
And that's how our direction system works. So sprite offset plus direction will basically figure out which way we're going. And for the image, we have to create a surface object. Again, it's an object in Enchant, and it's going to have some nice hidden features for us. All right, so we have to tell it the sprite sheet width and the sprite sheet height for this, and then which assets it's going to use, so the sprite's PNG file still, and we say player.image.draw, and we hand that in.
Very cool.
Okay, so that's how that sets up, and then you can give them any name you want.
Yeah, we'll walk through that when we get to the status screen.
And this is basically for stats, which we'll see later on. So again, this is just a bunch of player information that we've decided to give them, some levels and so on, and we'll come back to that.
So we've got our sprite set up, so we know what images we're using. We basically got our animation set up for our player already. We've initialized our player.
Correct.
So I guess
that player.
Yeah. So I guess we need to add him to the stage.
Right. We need to add him to the stage, and not what I meant to do. Sorry. Oh, I can't do that. So I have to scroll.
Yeah, it's down towards the bottom. We know that.
Oh, no.
I think you missed the control.
I did. My bad. I guess scrolling is the way to go for that. There we go.
There we go.
All right. So there's where our set player is being called. Okay. So again, it's when our game gets loaded, set player gets called, and set stage was in fact where player was being added. So there he is there, being added to the stage right after we're done adding the map.
Perfect. So what we're doing is we're saying, okay, we're going to add him to the stage. Right after we add our map, we're going to say, now add the player.
Yep.
And then what we're going to do is go back down to the on load and say, when you've loaded, you're going to load our maps up. Then you're going to load our player.
Initialize our player.
Initialize our player.
Initializing the player. Yeah.
And then we're going to go ahead and
set the stage for what we want the events to unfold.
Which makes sense because if we're making the map and everything for the stage and we're adding it to the stage, the last step would be to initialize the stage, right?
That's right. And that's effectively what we're doing.
Okay, great.
So at that point, we'd have a guy on stage.
Yes.
On the map.
But it's not really going to do us any good if we can't play with them, right?
It's not very fun at that point.
No, exactly.
No. So
Moving a player?
Moving the player is good, but how are we going to move the player?
Well, right now, we're thinking we want to target mobile.
Okay.
Right?
Right.
We've been talking with, this will work on the web and everything, and yes, we can do keyboard shortcuts on the web or whatever it might be. But there's also a lot of people out there that have mobile web devices, right? So like
That's right.
Maybe I don't have, maybe I'm using a Surface without the keyboard or something.
Right. So we could bind keys for the keyboard people.
Well, let's show them first how we would do the keyboard inputs, and then we'll show them the variation of putting it in.
In Enchant, again, we're going to use Enchant's system for this. Inside the game class, they have a keybind function. Now, here I've said A.
Now, is that binding A?
No, that is not binding the A key on our keyboard.
Okay.
Even though it's what maybe you want to do. This is internally inside the Enchant engine. It has what it calls an A button.
Oh, so if you think about a controller, with the buttons on the controller, we're saying this is the A button that I would be pressing on the controller.
And it has a B button and an up and a down and a left and a right for a
That's
D-pad
very handy
as well. So what we're saying is this part here, this number, is actually the key code for the key.
Oh, so it's the ASCII key code for the key that we want to bind.
In this case, 32, if you look up ASCII key codes for 32, it's the spacebar.
Ah, okay.
So we are saying whenever I hit spacebar, pretend it's an A button press. Okay, and again, because this is about the multi-platform sort of rollout, we want to abstract the individual input from what's going on. So our game just knows that, hey, you did the attack button.
Yeah.
But we don't really care how it is you trigger that.
And we're not binding it to a specific button, say on a controller or on a keyboard or whatever it might be, so that would limit our platform options.
So that's why there's this sort of abstraction of, oh, A has been pressed. But it doesn't mean A on the keyboard, it means an A button. So whenever I hit spacebar now, A will be fired. Okay, so that's the easiest way to bind any keys you want. Now, we also talked about, there were some images, for example, a D-pad.
Okay, so we should probably import all these images if we're going to.
That's right. So we've got that to play around with. If I can find, where'd the other one go?
There's A-pad.
Yeah, we didn't actually use that one.
Oh, okay.
But there should be I can't find the button one. Where did I put that? But there's another one actually, you know what? We took the buttons out, that's why. We used a D-pad image, but for the buttons itself, remember...
it has a built-in theme.
Right, there's multiple styles we saw in the plugin for the input, so we ended up deciding to use that so we could show that off.
So why don't you show them how to import an image file real quick?
Okay, well, again, we could use... you mean individual?
Yeah, actually in Visual Studio.
Sorry, yes. So in that case... you pick a folder that's relevantly named or wherever you want.
In this case, we're putting them all in the root directory, mostly because I believe there's an issue with Enchant's plugins needing to have it in the same root directory as the file that calls it.
Yes.
So
you can see, that we have an actual image folder and there's only one image in there.
Yeah.
But we actually put all the rest of the images in just the straight www folder.
So because of the way the Enchant plugin works, we want to make sure that it's in the same hierarchy level as the index.html.
There is ways to get around it, but that's the simplest.
The simplest way to do this.
Put them all in one file. So that's what we've done. And you just right-click your www folder, just like we were adding a source code file.
Yeah.
Okay, we can say add existing item, and then you could go find your image wherever that was.
And then you would just click add and...
Right, and then you would just click add. So I go into my www folder, and in this case, there's my pad image, and I would just hit add, and it's already there, so I'm not going to do it again. And it would show up. So that would be how we get it.
So the same way we did all the rest of the files.
It's exactly the same. So that's just a Visual Studios thing. We don't have to worry about it, really. If you weren't using Visual Studios, you could just drag and drop it into the www folder or whatever folder you were putting all your files in, and that would work suitably as well. Okay, so that's binding our keys, or a key, anyways. In terms of getting all of this to display, again, I got to scroll all the way down to the bottom here, and we have our set stage. So setting up our stage, that's the first place where really you can control something. The maps, we don't control. The player, we want to control, but not while he's initializing himself.
Exactly.
So if we go into set stage, and ignore this little debug button, I was playing around with something earlier, here is where we are setting up to use Enchant UI's plugin for the pad, the D-pad. They call it pad.
So when we're setting up our stage, we're setting up our controls on the stage as well.
Right. So that's what we've done inside our setup stage function. We've created a variable for our movement pad, and we've positioned it using the move to.
Okay.
So again, this takes in an X and a Y coordinate of the screen. Okay, so 0x means it's on the far left. It's not moving in any pixel number to the right. And I've pushed it down from the top 380 pixels.
Okay.
Okay, top left is 0, 0.
Yeah.
And it goes out from there. So then we add it to the stage as a child, and now it's part of the stage. And stage being our main screen at the moment.
Yeah.
So I could also add a button using the UI button class, which has its own styles. Okay, there's light style and blue style, and I believe there's one other style that we
dark style, I believe. Is
we didn't use it, and so I just made an A and a B button. Okay, so it sort of looks like an old gamepad, and again, move it to a position that I want. Okay, and then this time what I did a little bit differently. I said, just to show you how you can do this, game.currentScene. In case we were talking about that scene stack, so if I have multiple stacks or multiple scenes on the stack, okay, current scene is my way for just referring to the one that's active.
So basically what you're saying is if you did it this way and you said wanted controls on a certain screen, but controls maybe different controls on a different screen or other controls,
right.
This would be the way about differentiating it, right?
This would be the easiest way to talk to whichever one should be loaded right now.
Okay.
Okay. You can, of course, do it in a different way. You can also say root scene, but that's always the base level scene, not any of the ones above. So if you had something that you wanted to add to your original scene before you get back to it, you could do it that way as well. Okay. So there's different ways, and again, you can look all these up. There's different ways to add children to different stages or scenes, whatever
depending
you
on
call
your
them,
need.
Depending on your need, exactly. So I've just shown you another way to do it. So there's those two buttons being added to the scene, to the current scene, which happens to be the main screen. Now, in terms of because we want to do touch events and not keyboard events necessarily, when we want to do touch events, we have to use an on-touch start event listener effectively. So that just means that this object, which happens to be a UI button, is going to, when it gets touched, as soon as you start touching it, call
it's gonna fire
this function. Okay, now there's also on-touch end.
So that means when you release your finger.
Only when you release. So if you want something that's continuous, like when I push and hold the D-pad so that your character continuously shuffles along, you start because it will continually fire off. If I used end, it would only work when I let go, he'd move one step.
So it'd be something that if you wanted a single key press, like maybe a gun firing or something, you only want one bullet coming out at a time, you're just going to press it once, and it's only going to fire that event once.
Yes. Now, unfortunately, usually when you want to do that in a game, you want quick response. So when my finger goes down, I expect it to go off, not when I let go.
Yeah.
Okay, so we usually...
So bad example using the gun, but...
We usually use start still in that case, but when it fires off the first time, you set a flag to false so that it
won't fire again.
So it won't happen again, yeah. End and on-touch end are great for menus. A lot of the times, right, a pop-up will come up and we'll be like, yeah, wait, no, I didn't mean that button. And you're like, but I've already pushed it down, what do I do? Right, you drag your finger off and then you let go and it doesn't actually fire, right? Things like that. So usually menu buttons are the ones that use on-touch end because you only actually want to activate them when you let go, not as soon as you push down.
That makes sense.
Right, because you want to let the user think about it even though he's throwing it up and he's like, yeah, no.
We're all the same, right?
That one.
When we're reading our user license agreements, we're all like, okay, yeah, that's great.
So that is usually where we end up using on-touch end a lot more. And on-touch start we use more often in gaming. But we have to do some added extra functionality so that we get the response of shooting, but don't shoot a machine gun by accident, just a single shot. So we have to do some extra code for that.
Yeah. So I see down at the bottom, we'll skip over the facing code because we're going to come back to that. But I see down at the bottom in this thing is we actually have to move the sprite, right? So
that's right.
We've got the controls set up. We know where they're on the screen. We've set all that up. We've bound our keys. But we're not actually moving the character yet, so we need to take a look at the function that actually moves the character.
Right, we do. So let's see if I can just jump to player there. There we go. So we add our set player command in player. And then if I go down here, we have a attack player, and then we'll come back to that again. And we have a whole bunch of other things, but again, there's no move.
No.
So down here...
I'm thinking we want to move him every frame, right? We were talking about our updates and our loop.
So we do want a function that we can call when he needs to move. And the when he needs to move is going to be indicated by when the buttons are pressed. So this is how he moves. Okay, so let's go through that first, and then we'll see the last part, which is the part that binds the
button pressing
the button to actually call this function, which is move.
Hooking up our loop.
Right, so here is our move function. The first thing it has to figure out is what frame of animation are we on again. Okay, so we figured that out again using the sprite offset because it's a combination of sprites all in one file.
So I noticed it's saying this all over the place, and that's calling the player, right?
Right, so whenever you see this inside any, what we call scope, okay, it means referring to the object that this function exists in. Okay, so this, in this case, means player.
So we could actually remove this and put player, and it would do the same thing.
Sometimes.
Sometimes, but it depends on the instance, right?
Yeah, so we're going to go with this mentality because it's much clearer and there's not going to be any confusion. So in this case, yes, this refers to this guy. Okay, because we are in a function that he owns. So we're finding out his frame and his offset, and we add the offset to his direction times 2 plus the walk variable, which is always going to be 0 or 1. What this is doing is just left foot, right foot, left foot, right foot, left foot,
So it's giving
right
us that animation of him moving.
That's what walk controls. What direction is still our facing. Okay, and there are 4 directions to face. But for every direction, there's a left and a right step.
Makes sense.
Okay, so we have to take the direction we are dealing with, multiply it by 2, so that we skip over, say we were on the last direction, whichever facing direction that was, we'd have to skip over the left and right step for forward, the left and right step for backwards, the left and right step for going to the left, and finally, we'd get to the left and right step for moving to the right. So that would be 6 things we'd jump over, and so if moving to the right was the third direction,
it basically gives us a clean transfer between each movement.
So this is just the calculation to figure out which sprite we are on to move in that direction. So if you had more frames of animation per walk in any direction, you'd have to change that value, okay, to however many frames you had in every direction. So that's how we figure out which one we are on. And then we just check, well, is he moving? Okay, and that's going to be set by our buttons. And if he is moving, then we want to move him by some amount in X or Y, depending on direction. And we need to trigger the left or right foot animation step. So we just take the game frame value that we just calculated, we mod it by 2. Now, division by 2, it would just be /2, and if this is for the noobs, divide by 2, right? You get a number. 6 divided by 2 is 3, 2 divided by 2 is 1. Mod tells you about remainder value. So 3 divided by 2 is 1.5. That 0.5 equates to we had one number left over and didn't know what to do, right? So mod tells you just that value, 1. So when I mod by 2, any number, it will either give me 0 because 2 went into it perfectly, however many times because it was an even number, or it will say 1 because there was 1 left over because that original number was odd and can't be evenly divided by 2.
So we're trying to find the even frame.
No, well, in this case, yes. Well, so what it'll do is we're modding it by 2, and if the answer is 0, we invert it with a not symbol, making the answer true. So yes, we're talking about 0. Otherwise, it would be 1, and then any value inverted becomes effectively false, and so then we'd be talking about the other frame. So in this case, we are looking for the first frame of any given walk, and if that's true, increment walk by 1 to now give us the next frame.
Movement,
That's right. And then we can go ahead and mod equals it by 2, and it will give us that same value back. So that is just figuring out really what footstep we're on, and then based on that information and how we are moving, this is sort of complicated here, what we're doing, but what it's doing is, you know, I have that nice movement where in a tile-based game, you push forward and your guy walks, but if you let go right away, he slides perfectly until he gets into that next tile, right? Fully into the tile. That's what this code is handling. So it's taking the player's X or Y position, which is raw pixel value, you know, it could be 0 to 720 or whatever, going left to the right. And we mod it by 16, so it gives us a range from 0 to 15. If it's 0, we know he lines up perfectly with a tile. If it's not, we keep moving them in that direction.
Until we do line them up perfectly.
Until we do line up perfectly, and then we can.
So that way you don't
them.
have your player half stopping in between tiles or something like that.
You don't want him half walking and then half clipping a rock because he can't quite go around.
It would look a little odd if that was happening all the time, yeah.
That's right. So that's what this code is handling, and we use the is moving to figure out when we should stop moving because he's in a good grid or continue on. And then, of course, we have the else case for, well, if
not moving
is moving is false, then we can, that's the part where we check for input.
Okay.
All right, so if the game input is up.
So if we're pressing the up arrow or on our D-pad, if we're pressing up.
Then both the input object of enchant will say, yes, that up is true. So now that we know it's true, we set our direction to 1, and that just equates to, again, up. If I jump over to this, wrong file. Up, there's up.
Okay.
Okay. So if I count these as 0, okay, then these would be 1, and then these would be 2, and these would be 3. So that's our labeling of our indexes for our directions. And 1 was what we said we would get when we were setting it to, and that is the guys facing going up. So if I go back here, see, so if up is true, we set direction to 1 because they're the
0, 1.
second guy. Yeah. And then we want to say, okay, move upwards, which is in a negative direction. Why? Because again, 0, 0 is your top left corner of your So
as you move down, the numbers are getting bigger.
As you come down, the numbers are getting bigger. We want to go up, so we want to subtract values and move up the screen. So that's why we're putting his Y movement to -4 so that it gives him momentum, basically velocity, in that direction.
Okay.
All right. Don't worry about the clear status. That's something we'll get back to. And then right, it's the next direction. So we set it to 2, and we want to move in X, a positive value, because to the right is positive. And then left, same idea. It's the next set of 2 images, but we want to move now negative in X to go back towards the left side of the screen. And finally, down was the first set of sprites that we had in that animation set. So direction is 0, and we move positively in the Y-axis, which goes down the screen, and our value is 4. So that is effectively where we detect what is being pushed. But again, down does not mean just down arrow or anything like that, or D-pad down. Okay, there's that middle abstraction so that we can be device independent, and down will trigger either from our bound down key, which we can bind, or from our pad being that class itself or object itself. When you push on the down area, we'll report that as being true so we can do something about it.
Cool. So at this point, we actually have now our control set up so we can move our player around.
That's right.
So I guess the last step with the player would probably be adding the ability to keep him in the world, right?
Which is exactly. So if there's any movement in X or Y, okay, this is OR for those that don't know, 2 pipes, okay, that means OR. So if this is true or this is true, in other words, if either one of these values is greater than, is not null,
yes,
do this code, and we basically want to figure out where you are in the world, and it is a longer formula. There it is there. Again, you can see that we're dealing with 16.
Because our sprite's widths are 16.
Right, that's right. So we take your position, and we take the absolute value of your movement, and we are going to divide them in that. And this is an inbuilt if statement that they've done inline. Okay, so it's just like...
A fancy way of doing an if statement.
It is a fancy way of doing if, where it checks this thing, basically, or sorry, this thing over here, and if that is true, it does this. Otherwise, it does the thing to the right of the column when it's false. So if there's X movement, do this equation. Otherwise, set it to 0. If there's Y movement, do this equation. Otherwise, set it to 0. And basically just add that value to our current player's X or Y position.
And then the bottom, I'm guessing the bottom statement is actually checking our boundaries?
Exactly. This is where it's checking the boundaries. So if the player's X value that we just calculated, because first we want to figure out where he's going, and then say whether or not he's allowed to go there. We don't want him to move off screen and then be like, oh, I shouldn't be here, and teleport him back. So we check where is he going, and if 0 is less than or equal to X, and X is less than or equal to the map width, we know he's between the left and right sides of the screen.
Okay.
And if 0 is less than his current Y position and Y is less than the current map height, again, we know he's between the top and bottom. And so then moving would be allowed, and we'd call our move function on that player.
So
don't
we're
worry
checking
about this part.
Yeah, we'll
because
add that after.
That's when we get to collision checking.
Yeah, that's pretty neat though. So
as long as you had all of the move here up to this point, okay, and strip out that little bit, you could now move around in the environment, and it would work. I'm just going to fire up. Might as well do a little demo.
Yeah, show them a little demo of what we're talking about. And this is the finished version of it.
This is the finished version. I'll just do the parts we've talked about.
Makes sense.
So here we have our water, and we got our grass, we got some trees, and there's our D-pad. And so I can click on these, and if I click and hold, he'll go multiple. If I just click once, he'll do a nice full
and
animated
he's moving
step.
each tile every
That's
time.
right. And I can go in any direction I want. Okay, so that's what we've got so far.
Now, can you leave the screen to the left there?
That's right, and so we got that. So there you go.
How about the water?
And you see, also doesn't treadmill and grind his face.
Yes.
Right, like you see in a lot of games, right? They just keep walking. That's what happens when you're the professional.
Can you leave the water?
No, but I can go in the water.
Oh, so it looks like he's floating.
Right.
Very cool.
Now that is because, again, there's actually a water tile, just like the grass, on the ground.
So that's our half tile we were talking about
But then
earlier.
there's a half tile in the foreground map, making it look like he's keeping his head above water. That's exactly why we had in our sprite here. Oh, and I scroll. I'll just make this smaller. Sorry about that. There we go. So there's our half water. Okay, so basically there was a water in the background map, and then there was one of these water tiles.
So it allows him to slip
map.
between the two, so it looks like he's in the water.
That's right, because we draw that in front of the player.
Very cool.
And that's how we did that effect. So that's where we're at. We have a map, we have a foreground, we have a background, we have a player added in, and
we've covered a lot in that module.
Was a good chunk.
That was a good chunk of code there, and it's kind of nice to actually see something now that you have that you can actually move around and use and play with. You can kind of see the advancement, so it makes the time investment feel a little bit better when you see something coming out of it. With that being said, I think it's about ready for a break. I could use a break for a few minutes, and then we'll come back and we're going to talk adding collision.
That's right.
So
get those trees working.
We've stopped them from leaving the world, but now we want to stop them from walking through trees or other people, as well as we're going to add a status screen to keep stats for our player.
RPGs,
need that.
Everybody loves stats, right?
So. Yeah, that's great. Okay, we'll see you guys back in 10.